And you can pass that around. It's nothing special about it. It's just a regular long bait, but I sure had some fun with my hand transmitter on before we put it on the air one day when some of the other transmitters were off the air. I just put my, after they got it up, I put my hand transmitter on. It was beaming on Germany, and I was working all around the world with that 100 watts on that little field, 430. And guys from over in Indonesia and Australia called me in. And then we had a couple double lazy H antennas. And you can go to the antenna handbook to find out what double lazy H may describe. It's simply horizontal H antenna of a high angle radiation. And then we had another one which was called the steerable. And that's one that I'll show it in the video. In the steerable, I can probably best describe it like this. If you take a tennis ball or a golf ball, not a golf ball, sorry, a golf ball, not a football or a basketball, you take a round ball and you slice it right down through the middle. Okay, now you have two halves here. Now you take it and slice it right through the middle this way, one of them. You have a fourth of a sphere. You have a fourth of a sphere that sets plug on your table. You have a fourth of a sphere. If you can imagine that fourth of the sphere as being a reflector, and down in there, somewhere down here toward the ground, is a radiator that you can rotate on a track from this side to this side, and your antenna will shoot it like that. That is what we have in the steerable antenna. That design came from Voice of America. And one of our engineers, I think he had worked for Voice of America at one time. The VOA decided not to use it, and they authorized HCJB to build it. I'm not sure if they have a patent on it, how that works. But it wasn't original with HCJB, it came from that. But we had that antenna, and you're going to see a picture of it. And when we get down into the end of the video, toward the end of the video, I want you to notice that on your design curtain antenna, notice that little X at that one post there. We're going to be dealing with a feed line mismatch there on this little post down here. We're going to be dealing, Martha's smiling. We're going to be dealing with a feed line mismatch. And you're going to see a video of that. I had the job of correcting that. We had an antenna that was two bays high. It was just a straight, simple antenna that had one reflector over it. There's two towers with a reflector screen beamed to South America. Put up by a German audience. They paid for the antenna. We want a German broadcast in Paraguay. And we have a 60,000 watt transmitter on that, and it worked okay most of the time, but there was a mismatch in that feed line. And the engineers came in one day. Well, we went to a bigger transmitter, and we got a new transmitter around 100,000 watts. And by the way, our biggest transmitter was 500,000 watts. We had transmitters from the biggest one was 500,000. We just stepped down the power and increased. We have about 400,000 or 500,000 watts, several 50s, and then we have several 10,000 watts for the local Indian languages. We were broadcasting 49 meters for the local northern South America. Okay, getting back to this problem, there was a mismatch there. And at one point, the engineer going to put the new transmitter came in to me and said, Claude, we got a problem. Said that post got hot. There's a concrete post there, holding that heat line. And said the post got hot, it cracked. And said there's fire flying in the post from the air. Well, you know what that was. The rebar was the right length to get hot, I mean, to pick up the RF. And they actually changed over so it wouldn't bust. And I remember we have to have that problem.